Hi, I'm here with Kiran Somasundaram, and he's a software architect at Meta, and I'm here to interview him about his job. So what was your major, and tell me a bit about your current job?
Yeah, so I got a master's and PhD in electrical and computer engineering, and since then I've had multiple jobs in Google, Qualcomm, and right now at Meta. My current role is a software architect, which means I'm kind of responsible to figure out, like, given a system, what runs where, and how do you get the different pipes going within a software system.
Okay. And what does a typical day for you look like?
I'm involved in a lot of design, so it involves like talking to different people to understand like their components, what they're building, and then my job primarily is to make sure like these components can talk to each other and it makes sense from a systems perspective. So a typical day would be like talking to other engineers in the team, end of the day coming up with a document for the entire team to execute on, and wherever possible do some prototyping so that I'm head of the team and trying to figure out like what are the gaps in the system.
Okay. And do you find yourself doing like the same-ish things each day, or does it switch it up a lot?
Because we are in a research lab, it changes quite a bit. Like every month or so, we have like new projects coming up. So it's always like a new system that we are architecting and building out and prototyping.
Okay. And are you generally working on like one project at a time, or do you work on a bunch of different ones?
It'll be multiple features in a given
Okay.
project. So and typically, like, because it's a system, right, you have like multiple features and you can call each of them as a small project. Some of them will be mature features, some of them more early stage features. Typically, in my role, I have to execute against all of those features. The more mature ones, they're mostly autopilot, doesn't require a lot of intervention. The newer ones would require a lot of handholding initially. So I kind of balance my time depending on the maturity of the features.
What's like an example one of these features?
Let me see. There are certain things I can't talk about because we are in a research lab. So I work on like future smart glasses products.
Mm-hmm.
So some of the assistant capabilities, right? Like say today, if you buy a Ray-Ban Meta product, you can just wear those glasses and ask questions to it.
Okay.
So those are like features that are available today that are mature. How do you make those assistants become smarter, right? And the future projects could be like, how do you actually provide superhuman powers to those assistants, right? Like it should be able to perceive the world better than a human can. So those are like more advanced features we work on.
Okay. And what would you say is your favorite part about your job?
I think it's because we're a research lab, we work on advanced technologies. The fun part is like, working on the cutting edge and exploring things that are typically not available to product teams. That's very exciting. And also like, of course, the people, right? These are all like, I work with most of the people that I work with have a PhD, have deep domain expertise. So just working with them, talking, understanding their domain and how it fits into the picture, that's very rewarding for me.
Okay. And if you feel comfortable saying, what would you say is your least favorite part about your job?
Least favorite? I do have to sit in a lot of meetings. It's a part of my job because I have to talk to a lot of people, and because I'm an overall architect, I also have to be a super communicator in the sense that I have to make sure different workstream owners are making sure they talk to each other, and like if they're not, then it's my role to make sure I build those interfaces. And because of that, I have to sit in a lot of meetings. That is a part of my job. I've grown to enjoy it, but among the other things that I could do, that's probably the most, I wouldn't say stressful, but it takes a lot of energy out of me.
Yeah. And you said you had other jobs before this. What was like your first job out of college?
So yeah, right after my undergrad, I moved to the US. So I took up this master's program. I was at that time working mostly on, so both my PhD and master's were in controls, systems engineering. I was working on quad-rotor drones. At that time, the army was funding these projects. So my first job was in a small startup run by one of my advisor student. I was working on flight controllers for those drones. this is like very low level hardware and software stuff. This is where I started, and now I've moved up the stack.
And would you say that's like what a typical entry-level job looks like?
Define entry level. I mean, this is a job right after PhD.
Yeah.
So
okay.
that typically means that you've already. I mean, I had a few internships on my belt before I started. So I did a couple of software engineering internships at Google, and then I didn't. At that point, I was not ready to become a software engineer. I wanted to do more hardware systems work. So the startup opportunities were great with robotics back then. So yeah, that typically if you finish a PhD in electrical computer engineering with an intent to work on control systems, robotics was a great place to start. Yeah.
And those internships, was that how you like made money and sustained yourself in college? Or did you have another part-time job?
I had a fellowship, so that really helped.
Okay. Yeah.
And then the internships were more for understanding like what the industry kind of landscape looks like, right? Like, so I got a sample of like what a typical software engineering role would be, how much they would pay, whereas like electrical engineering jobs at that time were not, they wouldn't pay that much because it's like the demand was like a supply demand issue, right? Like there's like a lot of electrical engineers when I graduated, so at least I got to know like which jobs paid what.
Right. And have you always been like interested in this field, or have you had interest in some others?
Yeah, I was very passionate about robotics even growing up, so it kind of worked out well.
Was there like any specific moment that made you really want to go into this?
Let me see. I think a lot of school projects, right? Like how kids here have like, so I grew up in India, so we didn't have like first robotics and other things, but we had like other college and school competitions where you had to solve for like line following robots, for instance, right? So those things were exciting, and like we had like very limited hardware. We used to like code up things on microcontrollers. Like, back in the day, they were like timers called 555 controllers. Like 555 was a IC, was a timing chip IC. So you should put all of that in a breadboard and then write some very basic code. It was fun, like to see it, working in action end to end.
Okay. And in this field, do you find yourself like interacting and using skills from other disciplines a lot?
Absolutely, yeah. I think my role is kind of at this point is definitely a generalist role. So I do have to use my experience from like electrical systems. Sometimes, like when we were building the drones, there were like mechanical issues, like things would vibrate and whatnot, right? All of that learning is applicable for the current day job as well. So it's not very specific to like things that I picked up in grad school. I've been able to accumulate experience across over the multiple jobs.
Right. And do you do hiring at Meta or participate in that process?
I was a manager a couple of years back. I was involved in hiring. I do help my team hire right now, but now I'm an individual contributor, so I'm not directly responsible for hiring.
Right. And like what traits or maybe like experiences would you look for in a new hire?
For our labs, we are looking for people with deep domain expertise, right? So first thing is technical skill. And then the other signal we are looking for is like people who can work across ambiguous environments, because we're a research lab, it's not well specced out, like what kind of needs are there for these projects and features. So typically in our interview process, like we necessarily give a very ambiguous thing and try to understand if the candidate is able to navigate the ambiguity. That's how our interview process is set up to.
Okay. And do you know of like what like past experiences you would look for?
For a research role, we would look for things that are relevant for the PhD and see if it aligns with the products that we're building. So for software engineering role, we do look for people who can who either are generalists or we have signal that we can cross-train them quickly across domains, because it allows the team to be more nimble if you have like generalist software engineers. So it depends on the role. So we have research engineering roles, which are much deeper domain, and more generalist software engineering roles, which are allows you to be a little more fungible with your skill set and allows you to move across.
And would you have any like parting advice for someone pursuing a career in like STEM in general?
I wouldn't say advice, because this space is like changing so fast, and it depends on like if you want to graduate this year, right? The trend and the hype wouldn't say hype, but the trend is definitely on these AI systems and whatnot. So, but the speed in which, so one thing I would say is like, don't pick up something that's hot today, because the technology cycles are really fast. It's highly compressed. So when I was growing up, maybe it took 5 years for the next technology wave. Now it's happening on a yearly basis. So things do change quite rapidly these days. So if something is very popular already out there, it means like it's kind of in a either in a hype cycle or it's kind of in a peak in the product cycle. So pick for more fundamental things that can be applied across, like definitely math, right? Math skills are universally applicable to all the problem statements you're looking at. And for things like science, look for like problems that you want to solve 10 years from now, right? And then big skill set on that.
Okay. Yeah, well, thank you very much for your time.
Of course, yeah, it was good chatting with you.